It's the simplest, lightest, and most abundant element in the universe. We encounter it every moment of every day, not just around us, but within us. The molecules that form our muscles, our hair, and even our DNA are all saturated with hydrogen. It's in the water that sustains us, and it's the fuel that lights the sun. While most of the hydrogen we interact with is bound up in things like water and hydrocarbons, pure hydrogen has been a catalyst for human innovation. But not all of that innovation has been for good. The same element that helps create life also holds the power to extinguish it in an instant. Hello, everyone, and welcome to Meet the Elements, a series where I tell stories of humanity through the lens of the periodic table. Located at the top left of the periodic table, hydrogen has the atomic number 1. Its structure is the most basic possible, 1 proton and 1 electron, with no neutrons typically needed. This simple design is why hydrogen was, and still is, the dominant element in the universe, and why it continues to fuel stars. Being 14 times lighter than air, a small amount will rise rapidly. You can't smell, taste, or see it. Under normal conditions, the bond between two hydrogen atoms is very stable, but if you introduce a source of ignition, the smallest spark, it combusts explosively. While others had produced hydrogen gas before, the credit for its discovery goes to the English scientist Henry Cavendish. He wasn't just mixing chemicals, he was investigating what he called inflammable air. By reacting acids with metals like zinc and iron, he was the first to recognize the resulting gas as a distinct substance. He called it inflammable air because of its explosive nature when mixed with normal air. The most crucial observation came when he burned it. The reaction produced pure water. This was a revolutionary finding that proved water was not a fundamental element, but a chemical compound. However, it was the French chemist Antoine Lavoisier who, after reproducing Cavendish's work, gave the element its modern name in 1783. He called it hydrogen, literally meaning water former. This careful laboratory work set the stage for 2 centuries of hydrogen innovation. It's one thing to talk about producing hydrogen, but it's another thing to do it. So let's do a demonstration. Many metals can react with acids to produce hydrogen gas. This is because acids are known producers of hydrogen ions by definition, and when given access to an appropriate metal, it can rip electrons away from the metal, producing metal ions and hydrogen gas. As an example, let's look at zinc and muriatic acid. Now, muriatic acid is just an impure form of hydrochloric acid and is commonly used for cleaning concrete or bricks. As for the zinc, there are a couple relatively common items that contain this metal. First are galvanized nails or screws. The act of galvanizing plates a layer of zinc around the metal that makes up the bulk of the object. Another common object that contains zinc is the penny, at least pennies minted after 1982. That date is important because that's when the composition of pennies was changed to be 97.5% zinc. I start with muriatic acid picked up at the hardware store. After a little bit of initial setup, I take a file to remove some of the copper from a penny, exposing the zinc core underneath. Then, using a transfer pipette, I carefully add the muriatic acid to the water in the flask to dilute it. I stuff my prepared pennies into a balloon that I then stretch over the mouth of the flask. Once I have my flask clamped in place, I can work the pennies down into the flask and the acid solution. However, I discovered that the pennies were just big enough to not fit through the neck of the flask, so I carefully transferred the solution into a flask that would fit the pennies. Once again, stretching the balloon over the mouth of the flask, I was ready to add the pennies to the acid. As the pennies fall in, you can immediately start to see bubbles forming on their surface as the acid starts to eat away at the exposed zinc. I let the reaction run for a good while, letting the balloon fill up with hydrogen gas. However, I don't think I collected enough gas because as I held a flame up to the balloon, fortunately, the reaction was still going strong, so I simply put another balloon over the flask and let it collect more hydrogen than my previous attempt. So when I held a flame up to the balloon this time, On May 6, 1937, the Hindenburg airship arrived in New Jersey. It was filled with 7 million cubic feet of hydrogen gas. A static spark is believed to have ignited a small leak. The airship's skin, coated with paint containing powdered aluminum and iron oxide, also proved to be highly flammable. In just over 30 seconds, the airship was reduced to its metal frame as it crashed to the ground, and 36 lives were lost. 15 years later, a different kind of hydrogen-fueled cloud illuminated the sky. On November 1st, 1952, the Ivy Mike test completely vaporized the island of Lugalab in what is now the Marshall Islands. The fuel for this thermonuclear device was deuterium and tritium, heavy isotopes of hydrogen that contain 1 and 2 neutrons respectively. A smaller nuclear explosion was used as a trigger to compress these isotopes until they fused, releasing energy orders of magnitude more powerful than the bomb used on Nagasaki. This demonstrated how the same simple element that fuels the stars could also be used to create a weapon of city-destroying power. And while hydrogen has this hidden destructive power hidden in its core, that same power could be a potential source of energy for humanity. Ultimately, hydrogen ends up being more helpful than hurtful. Maybe not as much in its elemental form, but without hydrogen there would be no water, or sugar, or pasta, or, well, us. From its formation in the early minutes of the universe, to Cavendish's discovery, the Hindenburg disaster, thermonuclear explosions, and potential new energy streams, hydrogen has been a recurring element in both cosmic and human history. Hydrogen may be the simplest element, but it might be one of the most important elements in the universe. Thanks for watching. Hydrogen is actually one of my favorite elements. Its simplicity makes it very useful when looking at quantum and computational chemistry. And while I think I did a decent job giving a general overview of hydrogen, I want to know, are there any aspects of hydrogen you think I left out? Let me know down in the comments. And hey, while you're down in the comments, why don't you let me know what element I should take a look at next? And if you want to learn more about the elements of the periodic table, make sure to subscribe so you don't miss the next episode of Meet the Elements.